Dear students, we are discussing this exercise 13.1 and today we will continue this exercise. The question number 12 of this is find the limit x tends to minus 2 1 upon x plus 1 upon 2 upon x plus 2. When we put x equals to directly x equals to minus 2 in this given function, it becomes minus 1 upon minus 2 plus 1 by 2 upon minus 2 plus 2, that is simply 0 by 0 form. So it is 0 by 0 form. Now we have to firstly solve this given function. Now by cross multiplication in the numerator, we get 2 plus x upon 2x upon x plus 2, that is 2x upon 2x into x plus 2. Cancelling 2 plus x and 2 plus x in the numerator and denominator, we simply get limit x tends to minus 2 equals to 1 upon 2x, that is 1 upon 2 into minus 2, because 2x is here uh, uh, polynomial and it is 0, so this means that we can directly substitute x equals to minus 2 in this, so that is why the limit is minus 1 upon 4. Now the 15th one is limit x tends to pi sine pi minus x upon pi into pi minus x. Now when we put x as pi, we get sine pi minus pi into pi minus pi, that is sine 0 by pi 0, that is 0 by 0, so it is 0 by 0 form. Now taking here 1 upon pi in the denominator, or simply pi in the denominator is constant, it comes out from this limit, so it is 1 upon pi limit x tends to pi minus x upon pi minus x. Now as x tends to pi, which implies that transferring x to right hand side, it is simply pi minus x tends to 0, which implies that equation first becomes 1 upon pi. In place of x tends to pi, we can simply write pi minus x tends to 0 sine of pi minus x upon pi minus x. If we put h equals to pi minus x, we get 1 upon pi limit h tends to 0 sine h upon h. Now this is second order limit, its value is 1, which implies that it is 1 upon pi into 1, that is 1 upon pi. So the value of this limit is 1 upon pi. Now the question number 17 is find the limit of limit x tends to 0 cos 2x upon minus x upon cos x minus x. We can write this as minus into 1 minus cos 2x upon minus 1 upon cos x. We know that 1 upon cos x is twice sine square x by 2, which implies that 1 minus twice cos x is twice sine square x. So substituting these values, it is twice sine square x upon twice sine square x by 2. Because here if we substitute x equals to 0 in this, we simply get 0 by 0 form, which implies that limit x tends to 0. Now 2 cancels, sine square upon sine square x by 2. Now multiplying and dividing in this x square, that is sine square x by 2, sine square x upon x square into x square upon sine square x by 2. Now limit of product equals to product of limits, it is simply limit x tends to 0 sine x upon x का whole square into limit x tends to 0 x square upon sine square x by 2. Here limit x tends to 0 sine x upon x is simply 1, this means that the value is 1 square, it is 1 square. Now multiplying and dividing by 4, because here we have this 2 in the denominator of this angle of sine, we can write this. Now take numerator 4 out from this limit, it is 4 limit x tends to 0. Now x square upon 4 can be written as x by 2 whole square, it is sine square x by 2. Now as x tends to 0, we can write this as x by 2 tends to 0 x by 2 upon sine x by 2 का square. So this is 4 into 1, that is simply 4. So 4 is the required value of this limit. The question number 18th is limit x tends to 0 ax plus x cos x upon b sin x. Now taking x common, it is x into a plus cos x. Now this b sin x can be written as sin x into b, or this can be written as x by sin x a plus cos x upon b. Now break the limits, it is limit x tends to 0 x upon sin x into limit x tends to 0 a plus cos x upon b. Now limit x tends to 0 sin x upon x is 1, which implies that limit x tends to 0 1 upon sin x is also 1. It is 1 into a plus cos 0 upon b, that is a plus cos 0 is 1, 1 plus a upon b. The another one is limit x tends to pi by 2 tan 2x upon pi minus x minus pi by 2. When we put x equals to pi by 2 in the given function, we simply get 0 by 0 form. So put y equals to x minus 2. Now as limit is x tends to pi by 2, which implies that y tends to 0. So limit y tends to 0 tan 2 into y minus pi by 2 upon y equals to limit y tends to 0. Now taking minus common, it is tan of minus 2y plus pi, that is minus pi minus 2y. Now tan of 180 minus theta is minus tan theta, that is tan 2y upon y. Now this tan 2y can be written as sin 2y upon cos 2y. This, it is limit y tends to 0 sin 2y upon 2y into 2 cos 2y. Now when y tends to 0, 2y tends to 0, and limit 2y tends to 0 sin 2y upon 2y is 1, and 1 upon cos 2y, that is cos 0, is simply 2 twice 2 upon cos 0, that is 2 upon 1, that is 2. So this means that limit x tends to pi by 2 tan 2x upon pi minus pi by 2 is simply 2. Inshallah, in tomorrow's video lecture we will discuss the limit of some functions